Hello. Again, we'll wait maybe 1 to 2 minutes for people to join. Hi, Porto.
Hi, Pramana.
Have you set up?
Yeah.
Nice. Okay, so I think we can start. Welcome everyone to this week's tech session. Today our presenter will be Porto and Teodoro from his team. As you can see, Porto, you can take it away and you can say what you're going to talk about today.
Okay, can you guys hear me?
Yep.
I guess you can. Okay. Okay, so my assistant Theodora is off sick, so I will be taking the floor by myself today. But this will be the part 1 of a series of 2. So she will do the case studies, and she has a pretty cool demo for you next week, right? She will do a case study of some of the stuff that she has been doing herself, and a demo from something that demonstrates what the theory that I will present today. Right. So the topic is brownfield to greenfield legacy code refactoring. Right. This, I guess, is one way or the other every engineer's favorite topic. Right. Some usual background stuff, right? So this is essentially, in my opinion, is what constitutes entirety of the skill set required for software 1.0, right? And the whole idea is, right, once you master these skills, your job becomes fun, right? And you tend to find a lot of happiness in work. You tend to find a lot of confidence. You tend to be able to contribute. And in general, you're confident, right? You like coming to work, right? So this is essentially something that I put together, and folks should feel free to we can get into a discussion on this, right? But to me, this represents what software 1.0 is about, right? Software 2, I will have a different set of skills, but we can cover that, right? The main thing is this talk will focus on the legacy code refactoring aspects, right? And as you can see, right, the complexity of a system increases as you go outside. So clean architecture, up until clean architecture, you have a single system bounded context, or rather a single domain, and with a domain-driven design, you can essentially spread out to multi-bounded context systems design overall. Right. I think we've covered a bunch of stuff, and this is today's focus. We'll try and do some of the stuff in the upcoming weeks. And the usual warning from my side, right? Some of these techniques have learning curve. Definitely this particular topic, the legacy code refactoring, has a bunch of learning curve. Definitely try them out in pet projects, in katas, during the hackathons, during the FHL and so on and so forth. It's a great way to build a skill. You are feel free to approach me, and there's a bunch of work going on in Service Graph that is directly applying these practices, right? So definitely come and approach and sit with us. It doesn't have to be for 2 months. You can just sit with us for a week, come and see it, try it out. Right. The main thing is ensure that your EM approves these things before you try it out at work. Otherwise, I will get beaten up by your EMs, right? Right, because it's easy to kind of get excited and sort of try and them out, but then you will figure out like that, days have gone by, and you have to start afresh simply because nothing has happened, because these things have a way, have a learning curve essentially. All right, so my usual trivia. Anybody know what this is?
Some sort of Turing machine?
Okay, that's one guess. Anybody else?
Enigma.
Okay, that's the co-Turing machine, okay? Or Turing machine is co-Enigma. Anybody else? Okay, I actually don't know.
Calendar.
Sorry?
Calendar, something like this one.
Calendar, okay. It may be. So the thing is, right, this thing is this picture is coming from Michael Feather's working effectively with legacy code refactoring. Working effectively with legacy code, that's essentially the Bible and contains all the information that you will ever need for legacy code. I just picked it up from there, and so far I haven't been able to locate what this is, where this is coming from. My guesses are the same that Vlad and was it Daniel? I think they had guessed that. Those were my guesses as well, but I don't know for a fact. It certainly looks like Christopher, like the Enigma breaker, but can't say for sure, right? Okay, so today's agenda, right? So it's out of whack. Okay, so we'll go through something called a do content hit, and if you are familiar with this term, stop me right away. Right, we'll see what legacy code is. We'll start with the definition. We will look at what refactoring is. Then we'll see what legacy code refactoring is. Right. Then we'll look at something called the generic legacy code refactoring algorithm. It's the only algorithm that you need to know to refactor any legacy code. Right. And then finally, some tools and techniques, some very minimalistic tools. Actually, you don't need much. It's just you just need some courage and some willingness to take on some blows. But there are some certain techniques, there are certain tools that make your life easier. And then the next talk, we'll do a demo of legacy code refactoring. We'll do a case study. This is a real world case study that has happened, that is currently happening in the Service Graph code base. And then some bunch of takeaways and references. Right. So there's some questions I'm just checking out. I guess not. All right, so let's start with do content. Anybody know what do content it is? Okay, it's actually from right next door, so as in figuratively put. So it's essentially a case study, right? And let me give you some visualizations, then some numbers, and then let's talk through it. So this is essentially do contented is a single method. Okay, it's just one method, right? And this is the architecture, just one method. Okay, let me repeat that. This is the sort of the architecture of the method that was sort of they built it sort of before it was touched, quote unquote. This is sort of what it looked like. Okay, and I'll give you some numbers. This is just one method. Same method was developed for 20 plus years. This is in Office code base, right? So this is what, when you essentially type in a keyboard or when you essentially touch your document with your finger or your mouse or with your stylus, this is the method that gets or used to get hit. This method no longer exists. And it was developed for over 20 plus years, starting from 83 all the way till 2012, right? So same method folks kept on adding for 20 plus years, right? And just imagine the number of Office releases they did. And you can guess how critical this method is. Every keyboard hit, every mouse hit, every stylus hit, now with Android, with a bunch of other things, right? 18,000 lines of C++ code, one method. Is somebody's mind blown yet? 35 content types. So content types are essentially what is supported by Word, the set of stuff that you can put inside Word, right? And this is a method that takes in the initial, input, handles the initial input for all contents for Word, and 6+ platforms, right? Windows, Office, Android, tablet, iOS, Mac. 6+ input types, again, mouse, keyboard, fingers, stylus, and you name it, right? So just let me repeat this, right? 20 plus years of development, one method, 18,000 lines of code. This is the architecture. And this is what sort of the code was looking like, what you can imagine, right? And then there is this app compat stick. So app compat is essentially a division in Microsoft, at least I think in this operating system division, I think they have it in our division as well. App compat division is arguably the most powerful division. They can literally come and block you from shipping, right? This was started by Bill Gates like early on. The whole purpose of this division is to make sure that this Office documents or Excels or content that was created by, say, Word, I don't know, 1996 or 1988 or something, can still be opened in your current Word versions. You cannot break Office documents. You simply cannot break the customers. So application compatibility is essentially a complete, the enormous amount of Microsoft spends an enormous amount of effort in that. This is the reason why customers stick to the Microsoft products, right? Because they know that when we upgrade a product, we are not going to break their existing investments. So the whole idea is, right, you can develop something for 20 years and keep adding 18 lines of code and add functionalities. However, with the app compat guys watching over you, you have to make sure that the behavior remains identical from release to release to release to release. If there's a bug, customers often take dependency on a bug. So you can't even fix a bug by mistake, right? So the bar here is unimaginably high. And you guys know how much Office earns for Microsoft, right? Office is just, the next division. Maybe we should take a minute and let this sink in, right? Around about 2012, what they did was they figured out, they brought together a team, they figured out, and this is like just developers like you and me, right? So they brought together a team in about 2012 towards the end. By 2013, they had split this into 40 files. They had refactored this into 40 files with a lot of tests, fine-grained tests with 0 bugs. 0 bugs. Okay, let me repeat that, 0 bugs. So this is the initiative or the movement called Zero Bug Refactoring. And here is the white paper. So click on it, we can read through this if you want. I mean, if you have some time remaining, we can just go through this, right? This is right on MSW, right? Last night I was looking for this. And then I fired a search on MSW. This is one of the first thing that comes, right? This is exactly what is mentioned here, right? These numbers are from there, right? So literally 0 bugs, right? The whole deal is, right, with this app compat guys watching over you, you cannot even fix a bug by mistake, right? So you have to retain high levels of compatibility with your previous. So this is essentially what is possible. This is an extreme case, extremely successful case of what is possible with the techniques that you will essentially go through. We will go through this, right? In my career, I haven't done anything nearly as complicated as this, right? But this is one of the sort of demonstration of what is possible by just some sheer skill, right? So this is the kind of things, right? If you have this kind of skill, right, there is no such thing as brownfield project for you anymore, right? You can just get into a project and you can just deliver it, right? You can refactor it, you can break it, you can do whatever you want, and life becomes a lot more fun with this, right? Then you stop bickering about, hey, I'm not in a greenfield project, my life is miserable because I'm stuck with the brownfield. All none of it matters, right? This is why this skill is so important, right? That eventually you realize, right, no matter what project you get into, that eventually turns into brownfield project after a while, right? So which means that if you have the skill, right, suddenly you're invincible, no matter what the code base is, no matter what the type of code that you're dealing with, right? You go into your work with a sense of confidence, right? And you leave work with a sense of happiness and accomplishment. Anyway, so this is a case study. It's totally worth going through this. I think some of these guys are still here. I mean, I had sort of interacted with some of the guys back in 2012. Pretty sure some of the guys are still here. And maybe we can arrange for a tech talk from one of those guys. But this is a link. Check it out, right? Anybody's mind is blown with this. My mind still continues to get blown with this, but yeah, right. This is just fascinating stuff. This is extraordinarily fascinating stuff. Right. All right. So what is legacy code, right? Let's just come down to the ground floor a little bit and build from definitions, right? From first principles. Right. So legacy code is just code without tests. That's all, right? That business dependent, and even do content it didn't have a test. They had like sort of long range and acceptance and manual tests, etc. But nothing. It didn't have any sort of automated test. So legacy code is nothing but code without tests, right? And obviously business depends on. Otherwise, you would have deleted the code. What is it not? Right? It is not someone else's code. So you don't get to go and say, hey, this is someone else's code. So it's legacy code. It's not that, right? It isn't something called ugly code, right? There's no such thing as ugly code, right? It's right. So when you say legacy code, you're not actually meaning ugly code. You mean you have a very specific definition. It isn't code violating solid, dry, Yagni. These are some of the things that we went through in the session 0 to I think in this series. Although it most likely does, right? The fact that it doesn't have this test means this would have been violated big time, right? What it is very simple, right? It's code without tests. It's as simple as that, right? Any code, any block of code without test is a legacy code. It's as simple as that, right? I've specifically put that blinking here to drive home the point. Right. Some of the things is that this is common sense. Left to itself, entropy always increases. Entropy is essentially the disorder in the system, simply because as your block of code increases, the number of possible states, permutations in which you could have written the code, but it's all correct, increases. And therefore, the probability that you find your code in any one of the disorderly states that are, is higher, and therefore entropy increases, right? And corollary to this is all code eventually becomes legacy code unless you take, right? This is like a, refrigerator. Your room keeps warming up, so you actually have to increase the entropy in a global system to decrease the local entropy, right? We can come down the. Hey Charles, you have a question?
Yeah, I'm kind of curious about this definition and where it's coming from, because the way I thought about legacy code is that it's like not code that's not actively being worked on. So basically, when you work on it, it's code, but once it's becomes to the kind of like the support or like not being actively developed side, that's when it becomes legacy rather than this tied to tests. I'm kind of curious where this is coming from.
Yeah, so this is the definition of legacy code as per Michael Feathers, right? But let's not worry about who defines it, right? So the main thing is, right, you could define legacy code as the code that is not being worked on, but it doesn't give you anything actionable to do with it, right? Yeah, sure, it's not being worked on, but so what, right? However, if you define the code as legacy code as code without tests, right, then it's actually pointing you to do something with it. So this definition makes it a bit more actionable, what you should do with it, right? Which the other definition doesn't. And therefore, in my opinion, right, this is a more sort of, action-oriented definition, if you know what I mean.
Cool, thanks.
You could define it that way as well. You could define legacy code as something code is not being worked on, but like, yeah, sure. So what do you do with it? Right. So, but yeah, it's really how we define the things. Hey, Dimitri.
Yeah, I'd like to add to that question a bit.
Sure.
From the practical perspective, there is a lot of companies running projects, converting Ruby projects to something else, and they have a lot of unit test coverage, and the systems are good, but just the technology get out of the fashion, and the code becomes legacy. So I think this code without test, this is really extreme opinionated description of that. So I think it's not correct.
Yeah, like I said, right? We can define whatever we want it to be. I mean, nobody stops us really, right? What, in my opinion, is important is like when you define something or when you lay down a framework, right? Is the framework pointing you to something actionable, something that delivers value, right? But yeah, sure, we can define legacy code as something that is out of fashion or something that has not been worked on, right? That nobody stops you. So certainly you can do that. Right. For the purposes of this talk, though, there is a reason why we are defining legacy code this, and it goes back to what I was saying, right? It's when you don't have code without tests, you are missing certain guarantees, and therefore it becomes imperative that you apply a method to the madness, and this is the basis of the entire framework, right? So, and that's the reason that this is why we're defining this to be, what we're defining it to be. So nobody else any questions. So now the next thing is now eventually, right? I think this should be a common observation, right? Eventually, greenfield projects also become legacy, right? So it's not long ago that we started the file new project in Service Graph, right? It's just about last December, right? Service Graph isn't a legacy code yet simply because there is a bunch of and fair bit of testing, and testing keeps going on. But it's no longer a greenfield simply because it's no longer a fresh project, right? After 6 months, it's not a fresh project anymore. We've been working on it for a while. There are about 60 pushes to master going on every 2 weeks by a team of about 20 guys, right? So even something that was started as late as last year, December, suddenly has takes the favor of an old clone. But the main thing is, right, things tend to again go towards entropy, go towards legacy. I mean, if you're not writing tests and suddenly you're afraid to touch your code, like there are specific attributes, right? You will be very afraid to touch something that is legacy, right? Because you don't know how it impacts you, how it breaks you, right? So unless you know how to handle, unless you have the mastery over how to handle the legacy code, greenfield projects will become legacy because you write a project, you write a code, it's new for a while, then suddenly all of a sudden you start getting afraid, right? Okay, should I touch this? Should I not touch this, right? And finally, right, the refactoring aspects of this is a lot of fun, right? It's extreme. This is it gives you a lot of dopamine hits, right? Now I already told you about the do content hit. That is some spectacular success story, right? But then I think I'm pretty much sure that we can all talk about our personal success stories here, right? But certainly I encourage you to go ping these guys on Teams and just talk to them, right? What the deal is. What is refactoring again? So again, starting from first principles, the main thing is you are restructuring your code base step by step without changing its behavior, right? Without changing its observable behavior, what you can see from outside, right? Internally, a lot of behavior can change, but what is observable doesn't change. Right. The main thing is that you're retaining bug for bug compatibility, right? Now if you're doing it right, you will and often, right? Often you will see that if you have a very hit customer product, if you have something that has been being used by a lot of people, even the bugs in the system, customer have dependencies on them, right? So if you fix a bug, you have technically broken customers, right? So you can't do that, right? So the app compat group in Microsoft, when the OS goes through the operating system, Windows OS goes through release cycles, the app compat team takes very close, right? It's like a huge amount of investment that has been made in the application compatibility layer. All right, that's any separate engineering of its own. So that to make sure that if the OS was exhibiting a bug before and fixing of that bug will not result in significant business impact, only then the bug is fixed, right? So otherwise the bug is actually retained between OS versions. Otherwise, the customers are broken, right? And that is why you see Windows and Office and a bunch of these Microsoft products are such long, longevity. Right. And then, of course, you typically direct refactoring to solve the specific issues, right? These are the smells. These are the solid principles, and you essentially try to make them dry, right? And these are essentially just the basic things. There's really nothing much more to it. Everything else you can just, you're not going to need it right? You can ignite. The main thing about refactoring is, right, when you get into a code base, the lesser you understand the logic and the more mechanical the process is, mechanical as in more abstract the process is, the more fun it is. And it also means that since you're understanding the logic lesser, you're also not really concerned about, getting into discussions like, hey, this is a behavior, should I break it, should I not break it, and things like that, right? Right. So the main thing is, right, the general technique that I'll talk about it in a short time, right, that has nothing to do with the logic of the code that is in concern, right? So which means that it doesn't matter what framework, it doesn't matter what language, it doesn't matter what product it is, and the same technique applies everywhere. It's just a mechanical set of things that you need to do, right? Now here is a commit notation, right? And this is something, I think this is a pretty cool invention. I don't use it much, but I think when you're doing refactoring, I think this is a pretty cool thing to use, right? So what you do is you essentially say that, okay, when I'm making some changes to a code base, when it's something very critical, you typically tend to commit with this prefix, right? F means a feature, B means a bug, T means commit that has only tests. Small r is a provable refactoring. So I will come to what I mean by provable refactoring. There are provable refactorings and there are unprovable refactorings, right? A is something automated, like for example, control R, right? Or control R, control I, something that has been done by the tool without human intervention. So these are the automated refactorings. And bang, bang, bang is something, you meant to refactor it, but ended up editing the code instead, right? So the more rigor you apply, right, the more fun it becomes and the more, beautiful your result is, right? So this is a way to sort of get into the rigor. So when you start making a change does one thing and one thing only, right? And therefore, what is that one thing? Then you first plan it out. Okay, first I'm going to introduce this feature, or first I'm going to introduce this test in whatever order, but you stick to that, right? So this is one of the ways to structure your, refactoring, right? And this is I don't use the commit notation, but often my commits are structured this way, right? I don't tend to mix at least the last one with any of the previous ones, right? All right, so what is LCR? LCR is obviously take a legacy code and refactor it, right? But meaning but it's not as simple, right? The fact that it's legacy code, which means it's a code without test, means you can't just screw around with it, right? You can't just move it around because you'll just break it, right? And you'll break it in unknown ways, right? Or worse, you'll break it, but the few tests, 5 or 10 tests out of the 100 scenarios that you knew of, they will be running, but 15 important corner cases are broken, right? So your battle is lost right there. So you can't just take a piece of legacy code and just start screwing with it, which means you have to be mindful of certain things, right? So now what does it mean, right? So the legacy code refactoring is you're retaining bug for bug compatibility, right? This is very critical, bug for bug compatibility, right? In a code base without tests, which means a legacy code base, right? In order to bring the code base under fine-grained tests. Shit. Sorry, kids. Okay. Right. Now, in order to, so that's the purpose of the refactoring, right? The refactoring of a legacy code is simply because you want to not make it legacy. And remember, I said like the reason for defining legacy is for a particular reason, right? Like when you define something, what is the outcome of this? Outcome of this is it gives you a sequence of actionable items. However, if you define legacy code as something written in, say, out of fashion technology or something that is not being worked on, right? These things don't apply, right? I mean, you can call it something else and then these things apply, but I mean, it's just a name, right? So the whole purpose of legacy code refactoring is just you are retaining bug for bug compatibilities, in a code base without tests in order to bring the code base under fine unit test, right? That's the purpose. That's what it means. All 3 bits are critical, right? So you lose out one of these bits, then it's no longer legacy code refactoring, right? So suddenly you change it and there are a bunch of new features introduced and a bunch of bug fix that you didn't intend. That doesn't count as legacy code refactoring. And therefore LC plus R is LCR, right? It's whatever. Any questions, anyone? It's actually a fascinating topic, really fascinating topic. Okay, so now this generic legacy code refactoring algorithm, right? This is the silver bullet for all your legacy code refactoring needs, right? This is just the one thing that you need to master, right? What is that? Okay. So I'll do it in 2 passes. One pass, I'll just lay out the big blocks. Second pass, again, we'll go over the same thing, but explain each step in a bit more details, right? So the first thing is you scope it down, right? You isolate what code you want to refactor. In the case of do contented, that entire 18K lines of code was isolated. And recursively, I'm pretty sure they would have done it recursively, like out of that 1 block and out of that 1 block. Then this is important, right? You treat this entire code as a long sheet of paper, right? So technically, if you see, right, it's still a long sheet code of paper because at the end of the day, that's what the processor sees, right? It's a long set of instructions. So, and if you decompile the instructions, it stands to reason that this entire thing is one long sheet of paper, right? So you isolate, treat this as a long sheet of paper, which means just mentally think of inlining all the methods, right? So you just get a long sort of lines of code. Here's the critical thing, right? Identify the seams, right? So anybody know what a seam is? So a seam is a place where you can manipulate the system without changing the system in order to see different behavior. So this is typically an example of a seam is, right? If API call is going out, say call to a REST API, right? Or you have your code base and the code base is calling a library or as a Windows API, right? So then you will have a, one of the Windows Win32, some API call will be there, right? That is a seam because what you can do is, right, you can technically replace that library call with a shim, which is a wrapper to the library call. And inside the library call, you can sort of pass in new values without modifying the rest of the code. You can change the behavior of your code, right? So that's a seam, right? So what you do is you treat it as a long code sheet of paper, and then you identify the external callouts, right? So those are the seams. Now, why do you want to identify the seams? So that you can write pinning tests, right? Pinning tests are basically you feed in different data and you observe the seams and you sort of input new data from the seams and see what's coming out of the seams. And then, right, you have a range of inputs, right? So then at this point, you go through the code, you do it in a very mechanical way, but you feed in a bunch of inputs that takes the code path through various code paths, right? And then when you come out of the other seam there, you see what values is being returned. What you do is you pin them down. So you say that, hey, for this input, I'm getting this output. Just very mechanical, right? There's nothing about understanding the logic. This input, this set of input, I get this output. Another set of input goes through a different code path, I get another. So you try and cover it up. If a bunch of people do it, this is exactly how the do content it was done, right? So we should probably have a tech talk from somebody in that team, right? Now the pinning tests, what they do is, right, pinning tests are essentially just pinning down the behavior of the code, right? They are not full-fledged unit tests yet. They're not even unit tests. They're just pinning tests, right? Why are they important? Once you have the pinning tests, right, you can assume that the externally observable behavior of the system is not changing, right? So if you make sure that no matter what changes you have done in the code is not changing your pinning tests, that means by definition, your observable behavior of your block of code has not changed. Is that logic clear? I mean, stop me if it's not, right? Because you've pinned down the behavior, pinned down the externally observable behavior of the code, right? Then what you do is you apply a set of provable refactoring. Provable refactorings are something like, you can prove them to be the same. Like what's an example? Inline variable, right? That's a provable refactoring. Or extract a method. That's a provable refactoring because the reverse, you can prove it to be the same as that, right? You can just do the reverse, compare it, windif it, and then it'll be the same. So there are a bunch of provable refactorings like this, right? And there are about 6 or 7, right? And many of them are automated by tools like ReSharper or Visual Studio. So once you apply provable refactorings, right, then you can start identifying the smells like, this method is too long, so let's break it. This block of code is duplicated, right? And this is where, the theory that we covered in the simple design session, that the 7 smells, right? If anybody can name the 7 smells, I will take them out to lunch tomorrow. So feel free to stop me. So here is where you identify the smells and identify the solid principle violations, and then because you have written so many pinning tests, you can start now, applying provable refactorings into those. And one by one, you can sort of start fixing the smells. Like, so what could be an example of a smell that this particular 15 lines of code is doing too many things? So then what you do is you essentially split it into, say, 3 sets of 5 lines each, and then you make sure that, and you don't have to change it here. You can just extract it so that this method changes because of only one reason, right? So that's what I mean by fixing a smell, right? And then you refactor. Extracting a method is a provable refactoring. Once you've done that, right, now in the extracted method, you can easily write a unit test. So now you have an input, you have an output, that becomes a unit test, right? So similarly, you repeat this cycle and you don't have to go all the way, right? I mean, it's again that 80-20 rule applies, right? So 80%, if you spend 20% of the effort, actually 80%, it just looks remarkably better, right? For folks that have done it, they'll know what I'm talking about, right? Just the initial bit of effort makes it look remarkably, like it just shoots up the quality of the code base, right? And as a result, and as a side effect, you get back the, you get a set of tests also. So this is something that Theodora herself has been doing for the alert generation component. So this is one of the case studies that she'll talk through the next. She's also been doing the refactoring of the Custo pipeline to start generating. We are generating 1 alert now. How do you start generating 26 alerts from the partner signals that the Azure partners are sending us, right? So that is a refactoring that she's doing as well, right? So these are the case studies and very similar technique, right? She'll talk you through what design diagram she's built first. Then she's actually refactored the design diagram first and then refactored the code, right? So it's actually very beautiful to watch. And then finally, right, at one point you just say, okay, sufficient, right? This is a judgment call, right? Otherwise, you can spend your full day here, and after a point of time, it actually degrades. The quality degrades. You do too much refactoring, right? So that you have to make a judgment call. So this is essentially just the algorithm, right? This has nothing to do with the type of code. It could be Custo, it could be scope script, it could be C#, HTML, CSS, does not matter, right? It doesn't matter the technology. It could be Java, it could be .NET, it could be anything, right? Ruby, doesn't matter, right? Now, here is the reason why you don't define legacy code as something out of date technology, right? Because if you define legacy code as out of date technology, then then why are you refactoring it, right? But often, you guys know that we have in a lot of the banks, a lot of the major banks, we still have mainframes running, right, with COBOL, right? So, and they still need to deliver business value. So if you had defined that legacy code as something that is written in COBOL, then you wouldn't be able to apply this, right? So that's the reason why you don't define legacy code as something that is out of date technology or something that's not been touched. All right. So instead you abstract it a bit more, right? Okay, so now we'll take another pass through it and explain. Right, I think it bears going through it one more time, right? So in the isolation phase, what you do is you isolate the code to be changed. And again, it depends on architecture. The do content hit guys are actually build the architecture even before they touch the first line of code, right? And that was the architecture I was showing on the left hand side, right? Now you may need to do the entire cycle to make it open close, right? So then subsequent, you get the idea, right? So often doing one cycle will get you to one state and then you have to restart all over again, right? So these are like often you have to apply multiple passes through it, the same algorithm, right? Here, the whole idea of treating as a long sheet of paper is the lesser thinking, the better, the more mechanical, the better, right? Remember, this entire algorithm is you're talking at a very abstract level, right? You're identifying the seams. Seams is very abstract. It's applicable for Ruby, it's applicable for JavaScript, it's applicable for HTML, does not matter, right? What is an example of a seam in HTML code? Anybody can tell? It's your inline JavaScript handlers, right? Event handlers. So those are your seams in HTML code. Right. So the deal here is, right, at this stage, you want to just treat this mechanically, like very mechanically. You don't want to get sucked into the details of the code because they just hinder you, right? Because the whole deal is, right, since it is legacy code, since you don't have tests on it, anyway, you can't figure out all the business cases, right? So you might as well just not do it to start with. So points where behavior can be changed without changing the code, right? Which is mainly it's call out to external APIs, right? Or wherever you're reaching out to the external world, right? An example I gave, right? For a HTML sheet of, or rather a file of HTML code, seam is a inline JavaScript handle, because you can change that without changing the rest of the code, right? Or for C#, it's a call out to an external library, or for C++, it's a call out to a say Windows Win32 API. So pinning test essentially what it does, like I said, right, it locks the behavior in place. And this is where a lot of pairing programming discussion, the entire do content, it took 9 months, right? 9 months is fascinating, right? You just spend 9 months behind that simply because of the amount of business value. I think there was a principal engineering manager and plus a team of 4 people that together did it with support from EE. And I was closely involved with the EE guys at that point of time. Right. Here you use all the tools that are available to you. So you use code coverage tool. So you write a pinning test and see if it's covering all code paths, right? It's still not, it doesn't prove that it is not, but it's still useful information. You do something called a mutation testing. That's an example that we will see in the demo, right?
Play? Do you want to play? Could you ask Sergey?
Do you guys have a question, Alexander?
Sorry, did you ask something?
Oh, I thought somebody had a question. Sorry about that. Maybe it was just unmuted mic. All right. So you use various techniques here. Actually, the techniques are not that many, right? So code coverage, mutation testing, there's just a few, right? The main thing is ability to spot smells, right? Then apply provable refactorings, right? These are automated refactorings mainly, and recipes that are provably safe. The main thing here is the bug for bug compatibility guarantee, right? Right, and I will take us through what the core 6 core refactorings are. Right, I've given a list here, but it's actually very limited tool set, right? It's just practice. That's it. Right. Smells and violations are simply, do not repeat yourself. Fragility, rigidity, right? Immovability, viscosity, then needless repetition, needless complexity, and opacity, right? These are the 7 smells. And then finally solid, right? SRP, OCP, LSP, ISP, and DIP. Right, these are the smells. You spot the smells, and the more you do, the better you get at it. Right. Then so depending on the stage, right? So initial stages, like if you first start with legacy code refactoring on a block of code, your progress will be very slow, but then the progress accelerates. So this is what's meant here. So initially it'll be small, and then eventually, as your code becomes has more unit tests or more fine-grained tests, you can start taking bigger risks, right? But initially you want to be very conservative, very small steps, right? And then finally, of course, there will come a point in time where you've essentially done the job, and there's you've written a point of diminishing returns. So at that point of time, you're just better off getting back to your feature work, right? And this is the 9-month period where they just stopped the do content hit guys. The critical components of this is patience. The willingness to listen to the code, what the code is saying, right? And not forcing to make it do what you want, but instead, if it is breaking in a certain way, or if it is returning something, right, are you getting signals from that, right? If you're hearing it sharp, right, you can actually get a fair bit of signals from what your code is saying, right? But you'll have to be tuned, right? And then finally, being gentle, right? Being gentle is in like not forcing the code to do what it is not ready to do. These 3 things are also required on certain other activities. Can you guys name what that is? I'm pretty sure you can, Daniel.
Sorry, I wasn't paying too much attention right now.
Okay, I'll catch up with you. No problem. Anybody else can say what these 3 things, these 3 aspects where you use it most often? Like I can name at least 2 right now. Yeah, you guys never went on a date. Yeah. Or people that have raised kids, right? This is essentially the same sort of attributes. Right, these blue things, these yellow things. Then, right, it's actually pretty dense. Now, there really is just one algorithm for this, right? This is the only algorithm. This is the only legacy. So when you say legacy code refactoring, it's just this. That's it. Michael Feather's book goes deep into every segment of this. He's written this thick book. and he's covered a range of techniques, range of topics, right? And one of the fascinating things about that book, right, when I read through it, it's the kind of, he actually predicted that live unit testing, and he was saying it would be nice to have that live unit testing feature. And he actually predicted a bunch of the stuff that is a reality today. I think he wrote this book about 20 years back, right? But there is just one algorithm. That's the main thing, right? Rest of it is practice, practice, practice for 20 years, right? Now, is it hard to believe? If it is hard to believe, right, then ask yourself the question, right? How do you play tennis? You essentially just hitting the ball into the opposing court. That is all you're doing when you're playing tennis, right? Rest of it is tennis, right? So people like Federer start when they're 4 years old, and by the time they're 18, 19, or 24, they're they've played for 20 years. Federer, of course, is an extreme example, but an average top 1000s tennis player does the same thing, right? That is the only mantra in playing tennis. You hit the ball into the opposing court. That's it, right? And again, you practice here, right? It's the same thing, right? So this is some of the skills, right? Some of the skills that make you look like magicians are not all that complicated, right? The theory is very simple. Check out the do content hit case study. The same thing was applied there. Nothing different. It's the same thing, right? Now the key thing here is like this is any code base, any language, any stack, right? And that is why not the lesser you understand the code, the more generic your algorithm is, right? And your skill with algorithm doesn't suffer. You might get a little bit time to get bootstrapped into a completely. For example, if you put me on a COBOL code base, I might take a while to get bootstrapped onto it, right? But after I guess a month or so, I think it'll be just fine, right? Because then I will not be looking at what is written in COBOL. Instead, I'll be looking for seams. I'll be looking for tests, right? Right. So it doesn't matter code base, language, stack, right? And it's applicable to PowerShell, CSS, HTML, ARM templates. It's the same thing, right? Some of them have less of test tools. Some of them have less of refactoring tools. Some of them are, for example, ARM templates is very easy to make a mistake and not get caught. So the platform may not support some of the tools, but the technique is the same. What does it require, right? Like I said, right, very little theory, whole lot of practice. And the main thing that I found, right, is getting past the fear of making a code change. So for me, I didn't have an option. So my first 6 months into the company, my manager actually dumped me into the Visual Studio project system code base. That was like I think it was like a 15-20,000 lines of code that does the file new project experience, F5 experience, build experience, interfacing with the debugger, interfacing with the IntelliSense, that entire code base, right? And that code base covered C#, J#, VB, right? And I had to kind of find my way through. So, but 6 months into it, right, you lose the fear of making code changes, right? And then you accept that you are going to get whacked along the way by your boss. So because you will make a mistake or two, right? But eventually you get desensitized to that, and then becomes the fun, right? So its main thing is about getting past the fear of making code changes. And finally, right, willingness to move around code just for the heck of it, right? So if you suddenly see a variable that is not been named properly, just do a controller, and then just check it. Right, doesn't hurt. Or if you think a method is too long, just break it. You get your tools for free. The main thing is not putting this behind. So making a code change becomes a habit. Making code change is your instinct, right? So that essentially puts you right. So then when you are actually doing a legacy code refactoring, you won't be thinking twice. Should I change this? Should I not change this? You should just change it. Again, like I said, this is a repetition of that. I forgot to delete from the other side, right? So now tools and techniques, I think we're at the end of this session. I think this is just one section remaining for today's talk. Tools and techniques, again, not many tools. Again, this tools and techniques, tools are platform dependent, but techniques are platform independent, right? So HTML has less tools for refactoring. C# has a whole lot of tools for refactoring, and you get the idea, right? So characterization and pinning test, they mean the same thing, right? Characterization, pinning, and snapshot test, they have the same meaning, right? So you have something called an approval testing, where you essentially just take a snapshot of what your result is for a given set of inputs and then check it in. And the next time the test runs, we use this in the service graph code base, right? You can see an approve.txt or receive.txt, right? Next time the result runs, you compare the two, and if the two are different, your test fails. But approval testing is not something that you want to run long term with, right? Because it's very hard to debug. It's not helping. It's just a temporary phase based on which you can start refactoring. Right. Code coverage analysis is super important here, super critical here, because this tells you saying that, hey, your pinning tests have covered all the scenarios, at least all the visible scenarios. Mutation testing analysis. So mutation testing analysis is that you've written a bunch of characterization tests, and now for the heck of it, you change some, say for example, in the code, which is under the pinning tests, there was some plus equals 2. So you just change it into plus equals 3. Now, if some test fails because of that, then that mutant has been killed. Mutant is nothing but the variation of the code base. However, if changing a 2 to 3 has not failed anything, then you know that there is another test waiting to be written, right? So that's called mutation testing. Finally, a provable set of refactoring, right? You can check this out. There's a link to this. I'll send out this doc, right? Basically, rename method, function, parameters, whatever. Inline method, again, method variables. Extract method, introduce local variables, introduce parameters, introduce fields. That's it, right? These are the 6 core provable refactorings. And Arlo has what he has done is he's given a nice set of recipes, step-by-step recipes, right? And a few others, right? Some of these techniques we'll cover in the next talk when Theodore is giving a live demo. And finally, the commit notation is, if you are doing some serious refactoring, this is a good thing to sort of start following so that your teammates, at least for the PR, because after the PR anyway, it will get squashed, but for the PR so that folks can trace and give feedback, right? So if somebody is seeing it's probable refactoring, you probably don't need to review that. However, if something is like a bang, 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 right, where you're supposed to have refactored, but you changed it, that requires scrutiny, right? So it helps you there. Mocks are a good thing again, right? But eventually you have to have a mastery for developer skills, developer testing skills, where you don't need mocks anymore, right? The main thing about mocks is they create an illusion of decoupling, but really they are not decoupling anything, right? Build mastery of the L1 to L6 of developer testing. Check out the session 2 of this series. Again, IDE helps here, auto formatting, refactoring, RSharper is an awesome thing, right? Dimitri is on point to get us, oops, Dimitri, sorry. But anyway, he's on point to get us ReSharper setup for the org. Live unit testing, you already have it in your Visual Studio, right? It's a fascinating tool, right? And then some of the functional programming techniques, right? 4 aspects of function, 3 levels of types, right? The more you include this, right, the more locked your code base gets into behavior, right? Some of the mistakes you simply can't make with these things. That's why I had to cover this before. Plus pair programming, right? These are some of the tools and techniques. Right, pair programming of course means high bandwidth communications and rapid exchange of ideas. So if you're pair programming with somebody and if this person knows 5 things and you know 5 things and say 2 things are common, then suddenly 3 plus 2 plus 3, right? So 8 things both of you know together. So this is the end of this session. We can discuss some stuff if you guys have. Right, this is just fascinating. This is a fascinating topic, right? It's a fascinating skill set to build, right? You can definitely come over and join our team even for a little bit and see. We are doing this something called killing this bridge or killing the hairpin. That will involve a bunch of these techniques. So that's work that is in progress in the next 2 months, 2-3 months. All right, unless anyone else has any questions, Plamena, it's all yours.
Okay. So thank you, Partha, for doing the session today. And thank you for everyone for joining. If anyone wants to sign up for the next session, you can use the feedback form. And also if you want to write the session, you can use it again. And yeah, I hope everyone has a nice day and see you in the next one.
Bye-bye.
Bye-bye.
Thank you.
Thank you. Bye.